Hi everyone, so here we are on chapter 11, and for chapter 11 we are going to split into two parts. So we will be talking about sections 11.1 and 11.2 in this lecture, and then you're going to have a test on just those two sections later this week. And then we will do sections 3 and 4, and that will be later, and that will be a separate test. All right, so here we go. Okay, so thermochemistry. What do you think that the prefix thermo means? All right, so thermo means heat. So we're going to be talking about heat. Heat being released or heat being absorbed in a chemical reaction. All right, so heat is either gained or lost in a chemical change. That's what that says right there. Okay, and also, not only in a chemical reaction are we talking about heat being gained or lost, but we're also talking about in physical changes, such as going from a solid liquid to gas. So we're going to be talking about those energy changes. All right, so just in general, this is your definition for energy, so you can read that, and it's already in your PowerPoint notes. And so basically what happens in a chemical reaction is that the bonds are broken, and then new bonds are being formed, and while that is happening, we might have some energy that is left over, or we might need to actually absorb a certain amount of energy to break those bonds. And now we're going to talk about heat. So the variable that we use to represent heat is H or Q. It depends on what textbook you're using and what variable they like to use. So make sure you are familiar with both variables. Q and H both represent heat. This symbol right here, delta H represents the change in heat. Okay, the change in heat. Anytime you see that delta sign, it represents change. Your reactions can either be classified as endothermic or exothermic. And so that just means that heat is either going to be gained or heat is going to be lost in a chemical reaction. We also have what is called the law of conservation of energy. So energy is neither created nor destroyed, so the amount of energy lost equals the amount of energy gained. So first we're going to talk about exothermic reactions, okay? Exothermic reactions. So your delta H value, you see that little negative sign? You will actually have a negative number, okay, or a negative value for delta H. So the negative sign is just indicating that heat is being lost, okay, that the heat is being lost. And so in general, if the heat is being lost, then that means that your surroundings are getting warmer. Okay, the surroundings are getting warmer. So you can see in this diagram how the heat from the system is going to the surroundings. So you will actually feel that heat being released, okay? You will feel that heat being released. So you can feel it. It does get warmer. And that's how you know that it is an exothermic reaction. So another way that you can remember exothermic means it's losing, kind of like exit, like leaving. So that is one way that students remember exothermic is losing heat. Now we're going to talk about endothermic reactions. So endothermic reactions are positive. You have a positive value for delta H, and that is telling you that the heat is being absorbed, okay? Heat is being absorbed, or what we like to say, heat is being gained into the system. And your surroundings this time are going to get cooler. Okay, it's kind of like you have to think about it in terms of it's taking heat away from the surroundings, therefore making the surroundings cooler. All right, so this is endothermic. This is a diagram for the phase change of water. So liquid down here, vapor, which is gas. So if we take a look on this side right here first, so liquid going to the gas phase. So if it's going from a liquid to a gas, notice that it says it is endothermic, okay? So this is not a chemical reaction that's happening. This is a physical change, which is different. So if it's going from liquid to gas, it is an endothermic process. It has to absorb heat from the surroundings in order for it to go to the gas phase. Then, if we look at the other side of the diagram as it is going from a gas to a liquid. So this is exothermic. This process is exothermic. And that's why you see that they have listed there a negative sign for that physical change. And then over here for the endo, that one was positive. Now we're going to go over heat capacity and specific heat capacity. And we're going to be talking more about energy, calories, and joules. So that's what this J here stands for a joule, which is an energy unit, and this is how you spell joule. And then you are familiar with calories. So yes, calories give us energy, all right? And so here's your definition for a calorie: the quantity of heat needed to raise the temperature of 1 gram of pure water 1 degree Celsius. Okay? So the amount of heat to raise the temperature 1 degree Celsius. And here's a conversion. 1 calorie, and we call this a big calorie. Notice that this is a capital C here, and then on this side this is a little c. So I call that one a little calorie, the lowercase c, and I call this one a big calorie with a uppercase c. So 1 big calorie, which is the same thing as 1 kilocalorie. Remember, kilo means 1,000, and that's how we get 1,000 little calories. So, and this big C calorie over here, that one's also referred to as the nutritional calorie. Okay, the nutritional calorie. And so you will need to learn how to convert back and forth between joules and calories. Make sure you pay attention to the lowercase c versus the uppercase c. And those are your two energy units that we'll be using in this class. And that's the conversion factor for it. You don't have to memorize that number. That's a conversion factor that I will have provided for you on the test. Now we're going to talk about enthalpy. Enthalpy is the change in heat. So anytime you see a delta H value, it's referred to as enthalpy, the change in heat. And so here's an equation here. This is for the what is called the specific heat capacity equation. And yes, you will have to have this equation memorized. Sometimes I leave out the multiplication signs and just write it as delta H equals M times C times delta T. So we call this the MCAT equation. MCAT equation. So M stands for the mass, C is the specific heat capacity, and that number is either provided for you in the question, or you can also find a table in your textbook with all the specific heat capacity values. And then delta T is your change in temperature. So don't forget, the delta sign represents change. So to calculate the change in temperature, it's final minus initial. Okay, final minus initial. This is your definition for specific heat capacity. Every substance has its own specific heat capacity. So it's the amount of heat required to raise the temperature of 1 gram of substance 1 degree Celsius. So here's a question here. If we're talking about water versus iron, so iron like a piece of metal, so which one has a higher specific heat capacity? So specific heat capacity, you have to think about it in terms of, okay, which one is going to take more energy to raise the temperature? So which one's going to take more energy to raise the temperature? So you have to really, really think about it. A lot of people will probably say right away that they believe that it is the iron that would have a high specific heat capacity. But iron actually has a very low specific heat capacity. So let's think about it. Which one is going to get hotter faster? It would be the piece of metal, right? The piece of metal would get hotter faster than water, like a puddle of water. And so that means that it takes very little energy to heat up that metal. So it has a very low heat capacity because it takes very little energy to raise the temperature 1 degree Celsius. Whereas if you have a puddle of water on a hot summer day, that puddle of water, it'll be warm, but it's most likely not going to burn you, right? So that means that it's taking more energy for it to heat up. So it's taking more energy to raise the temperature 1 degree Celsius. Therefore, water has a higher heat capacity than iron. Now we're going to talk about thermochemical equations. So what does thermo mean again? Thermo means heat. So in these thermochemical equations, you are going to see the heat being added to the chemical reactions. So here I have two examples. You can see that the heat here is added in a chemical reaction. So that's just what a thermochemical equation looks like. Now, one of these equations represents an endothermic process and one represents an exothermic process. Now, notice the location of the heat. This one is on the product side and this one is on the reactant side. So then you have to go back to your definitions for endo and exothermic. So exothermic means that heat is being lost, okay, that the heat is being lost. So to you, which one looks like heat is being lost? Does that look like the one here on the product side or the one on the reactant side? So the one that is on the product side over here indicates that this is exothermic. Okay, that one is an example of an exothermic reaction. You see the heat being released, so it would be on the product side if it represents an exothermic process. Therefore, this one over here represents an endothermic process. So if the heat is on the reactant side, that is telling you that heat is being absorbed in order for that reaction to take place. Therefore, it is an endothermic process. This is another way that a thermochemical equation could be represented. So you have the chemical reaction, okay, it's written here, and then after the chemical reaction, off to the side, it gives you the delta H value, okay? So it's telling us that the delta H value equals negative 890 kilojoules. So is this an endothermic or an exothermic reaction? So you see the delta H value, and it's a negative value, so therefore it is exothermic. Okay, exothermic. The heat is being released. Remember, that's what the negative sign means. Heat is being released into the surroundings. I would like to do a sample problem with you on specific heat capacity. So if you can get out the Chapter 11 worksheet, the one that is titled Specific Heat Capacity Practice, we're going to do number 1 together. Okay, so in number 1, it says how much energy must be absorbed by 20 grams of water to increase its temperature from 283 degrees Celsius to 303 degrees Celsius. And it says that the CP, that little subscript P just means at constant pressure. So it gives you the heat capacity for water. So we're going to use the MCAT equation. So delta H equals MCAT. Okay, so we're going to plug in the mass. The mass is given to us, it's 20 grams. The C is the specific heat capacity that they gave you in the problem for water, which is 4.184 joules per gram degrees Celsius. And then delta T is the change in temperature, so final minus initial. So you take a look over there. Okay, so it's 303 and then minus the 283. So let's see if I can do my math today. Okay, so that's just a difference of 20 degrees Celsius, right? So that is your delta T. All right, then all you do is put that into your calculator and multiply it, and then also see if you can figure out what the units are going to be. So if you put this into your calculator correctly, you should get 1,673.6. And if you wanted to round that to just 1,674, you could do that. Or if you wanted to round to 3 sig figs, because this has 3 sig figs in it, you could do that also. So if you only wanted 3 sig figs, then it'd just be 1, 6, 7, and then 0. Now let's take a look at the units though. All right, so grams here cancel. The degrees Celsius cancel. Therefore, your answer is left in joules. Okay, joules. And remember, joules, that is an energy unit, and that's what we were looking for because the question was asking how much energy. So that's why we wanted our answer in joules. So if you turn your paper over to the back, that worksheet, on the back it is titled Thermochemical Equation Practice. So I want to go over problem 1 with you. And this is the equation. It's already balanced for you, but you should always double check the equations to make sure they are balanced correctly. And if we read the question, it says, based upon the thermochemical equation given, calculate the heat associated with the decomposition of 1.15 grams of NO2. So remember, you only need 2 pieces of information that are in the problem. You need the number and the question. So let's write all those things down. So it says calculate the heat associated. So then that's the heat over here. This is your delta H. That is heat. So that's why I'm putting a question mark underneath the heat. And the grams are given for NO2. So this is 1.15 grams of NO2. Then we're going to draw our arrow going from the number towards the question mark. So yes, look, we can do stoichiometry with these thermochemical equations, and I'm going to show you how we can do that. So start with the number 1.15 grams of NO2. We have to convert these grams into moles first. So if you go back and remember stoichiometry, grams here, therefore we want grams on the bottom of the next step. And then, in order to find the mass of NO2, you look on your periodic table. Add up 1 nitrogen and 2 oxygens. So let's go ahead and do that. So we know, let's see, nitrogen is 14 plus 2 oxygens. So that's a total of 32, which gives us, pen option, 46 grams. So make sure you double check my math. 32 plus 14. Okay, yeah, 46 grams per mole. Now we're going to do the mole-to-mole ratio. So you can do a mole-to-mole ratio with the heat. Okay, so do a mole-to-mole ratio with the heat. So remember, the one you're going to goes on top. So just put the heat on top, 67.6 kilojoules. And then this is your coefficient for the one that goes on the bottom, 2 moles of NO2. And that's it. See how your grams will cancel? Your moles will cancel, and that will give you your answer in heat, which means you want energy. So it could be in joules or calories, or any form of a joule or any form of a calorie. So now, let's put this into our calculator. So 1.15 divide by 46 times 67.6 divide by 2. And I get, let's see, what is this, 0.845, and I want 3 sig figs with my answer. That is 3 sig figs, and then my units would be kilojoules. And that's it. So you can see that you can do stoichiometry very easily with thermochemical equations. So that is everything you need to know for the first part of Chapter 11. So this test, you will need to know the difference between endothermic and exothermic. You will also need to know how to use the MCAT equation and how to do the stoichiometry with the thermochemical equation. Okay? All right, see you later. Bye.